let's have a look at the second derivative. Okay, the function y is equal to x cubed take away 3x squared has a first derivative 3x squared take away 6x. And this function tells us about the gradients. Now, the second derivative, which is 6x take away 6, this tells us about concavity, whether the cubic function is concave up or concave down. Now, we already know a little bit about this cubic function because it's positive. And with positive cubics, it follows this shape. If it was a negative cubic, it would follow that shape. And so to the left of the cubic function, we know that it's concave down. And to the right of the cubic function, it is concave up, okay? As represented by down curve and up curve. So the second derivative will tell us whether it's concave down because its value is going to be less than 0, or in other words, negative. For concave up, the second derivative is going to be greater than 0. Well, what do you think is going to happen right in between the two concavities? We're going to have what's called a point of inflection, and it's not going to be negative, it's not going to be positive. The second derivative is going to be equal to 0. Okay? So using this example, let's solve the values of x where we have concave down, a point of inflection, and concave up. Start with the point of inflection. Okay, so 6x take away 6 is equal to 0. That means 6x is equal to 6 and x is equal to 1. So therefore, the point of inflection is at x equals 1. Nice and simple. So we're expecting all the values left of x equals 1 to be negative. Here we go. Let's trial a number like x equals 0 this time and see what happens. 6 times 0 take away 6 is equal to 0 take away 6, which is negative 6. Negative 6 is negative, and it's less than 0. We can say, therefore, it is concave down. And one more to go now. Let's choose a value to the right of x equals 1, like x equals 2. So at x equals 2, we have 6 times 2 take away 6, which is equal to 12 take away 6, which is equal to 6. Well, that's obviously greater than 0. Therefore, it is concave up. And there you have it. So I'm just going to show you a quick little way to illustrate this for your exams. Okay? So we know that when x was to the left of 1, we had the second derivative tell us that the value was negative, smaller than 0 is negative, and the concavity was concave down. Okay, there's our symbol for concave down. Then at x equals 1, we had a point of inflection. And the concavity, oh sorry, my partner wrote that in the wrong spot. So this was equal to 0, and we had a point of inflection. Then lastly, to the right of x equals 1, we have x equals 2, and we found that it was positive, it's greater than 0, and it was concave up. And there you go, nice little table to put in your exam when you do these questions. Okay, good luck with those.